Hi guys, I'm Excel and I want to share with you some of the cool effects I did before. This is a short video of a test I did while learning Houdini, and you can watch my Behance for details. This CG also got 2 labels on Behance, which I am also very happy about, and it can be regarded as a reward for my persistence in learning. Based on the intentions of the friends in the group, this lens was selected for explanation. This is a dynamic tutorial on cell particles. I created this effect in Houdini and it covers some interesting tips that are beginner-minded friendly, including how to set the emission form of the particles, how to control the dynamics of the particles, and how I render in post, etc. You can appreciate the difference between Houdini and C4D. There will be a quick demo board here, which is provided to experienced friends without watching the full operation video, to quickly understand the production process. Save time. Of course, you can also follow my official account, which has detailed graphic parts, and the effect is even better when used together. Of course, there will be a free and complete production process in the future, and we will meet you soon, which is to help beginners who want to learn. I will put it on the shopping of various platforms. If you want to get it, you can choose to buy it yourself. In any case, you are very welcome to support me, and at the same time I am happy to answer your questions. Feel free to follow me or join our group where we share cool stuff and help each other. You can link it in the commentary or send me a private message today. Thank you for watching here. Without further ado, let's get started. This is a quick demo tutorial for us, mainly to provide ideas for skilled friends. It is mainly made up of 2 parts. The first part is a ripple on the outside. And you can see that it has a ripple effect. The second is the drifting particles inside, which can be seen to be more disorderly, but overall, it is a little more beautiful. Okay, let's look at the first part of the production, which is the method of making the ball outside. I built a new ball here and showed you my section. The segment is 16, try to be higher. Then, here I gave a wave minus making, which is equivalent to a displacement of the CCD, which we call mountain. And then, I directly use this node, which can produce this kind of friendship ripple effect. It's actually very simple. It has a target point on this side, and you can see where I'm moving my target point, and it will create this ripple effect. This is not a solution, it is real minus time. Okay, then I'll do some for it here, which is actually a major production process of our outdoor ripple ball animation. Here, I made a collider in the left column. And you can see the C-leasing source node I used here. It is mainly used to introduce our subsequent particles to play a role in a collision boundary. To the left of it is the output of our goo, which is our original model. Here I scaled it up a bit, because my particle emission behind me was emitted from the center, so I narrowed it down to 1 emission source. I don't want it to be a big emitter. Then look at our right, and what we output on the right is our VDB. Okay, then we did some spins, and we went to our camera to take a look. It's roughly just such an animation. Okay, here I exported a node to facilitate later rendering and 3D. Come to our particle making process. Here I also give a ball. Then, I also give a mountain node to make my surface irregular. Here we animate mountain. You can do animation. Just change its broadcasting mode here and check it. I'll change it to this. You can see that it will produce an animation. Then give a normal N property, which is its discovery. Here I use work to make a mess. You can see that they're black and white here. The white one is the area where I want my particles to be launched at the end. Here you can understand that it is a vertex map of C4D. Here I am using a noise. Then multiply by the properties of time. In fact, it is a 4D broadcast. And then go drive it. Here I have a CD so that I can observe it. Here I give 1. It can control the speed of our time. I can see it when I play it. If you pull the value higher, you can see that it flashes quickly. This is based on personal ambiguity. Then go down. Here's a V attribute. It is to discover to convert it into a V. We can take a look at this V minus property. Here are some random sizes made. Then, here is to increase the whole value. Make it more random. And here I just shrunk my emission so it's very small. It is small in the world coordinates. Then give up. Making it launch will be a little richer. Okay, then let's scatter some points on our sky nodes. Sprinkle some on our mask attribute. After that, I give a density attribute. This will be useful until we get into pop. Let's skip it here. Enter our popnet. It's our particle simulation. Let's take a look at what the whole effect looks like. One of the states it presents is to diverge particles from our center point. On our central area, it's particles. It doesn't create some disturbances. It's almost on the edge when you see it create some disturbance. And the particles will concentrate on these. Let's take a look at what it just brought in. It was launched from the center and then hit our collider. In fact, this effect is generally okay. But because I wanted to give it some more variations, let's talk about the ray minus entry of colliders first. We use a stake object. This part of our original ball. One is Guan is ours. It is a B that we gyrate. Ours is used here. Then here the mode is volume. Then place our VDB here. Then remember to take this invert time. It is a collision inside the ball. You can look at it. It should be that it will produce this. But it actually looks pretty cool. Wait, check it. Let's see what kind of effect it is when it is imported by default. It can be seen that it is very disordered, because we give a lot of money here. Then, there is an effect on all the particles. It goes back to the effect we just entered. So, how should it be achieved? If it is in CCD, then you may think of using a spherical field. Go and give it a range. For example, near the source of the emission. It does not produce disorders. It may cause disorder outside. In fact, we also use this idea to produce. It is nothing more than creating such a spherical domain. Then, I use a simple fact here. It is to calculate the speed of one of our particles. Then, one of the speeds I tested here is 0.4, which is a better value. What does it mean? It probably means when the calculated value is less than 0.4, it will receive a strength of 1.5. It is not less than 0.4. That is when it is greater than or equal to 0.4. Then we can think about it. When the particles are first emitted, its speed is maximum, so it's greater than 0.4. It will slow down, because wind has resistance. You can see that there is an air resistance here. It slows down the particle. At this time, when the particles are in less than 0.4, it will slowly produce this stable force. It will look like this. You can see the middle piece at the beginning. It will not produce stability. When it goes outside, and this value will depend on the size of your scene and your speed settings. It may just be a little tester. Here I give another pop drag. Let it slow down as a whole. Good. Next comes our most critical effect. It's about making our particles a little brushed, where the particles are absorbed, close to our dense emission sources. I just don't want to absorb too many particles. It can have, but not so much. The back glows when rendering. You will find very bright, very explosive. Good. So what is the whole idea? Here I made a simple gesture. Let me explain the idea. Here we have 3 areas with different types of balls. Blue means the particles are very sparse. Maybe then yellow is a little denser. The red color is where our density is concentrated. It can be said that it was just launched from the source. These are the most densely populated areas in our world. And maybe these places have a slightly more moderate density. And then the outside might be the smallest. The effect we want is that we want the blue and yellow areas to be closer to our read area, which is the densest area. To move particles in the lake bell, you need the most basic 2. One is its direction. The second is the displacement. That direction is vector. The resulting displacement may be the size of some of the numerical values. Suppose each of our particles can produce 0.1 particles with each other. The red one is the densest. It has 10. It will produce a particle of 1 for the blue. Yellow will produce a 0.5 grain for blue. The blue color will actually produce 0.1 particles for red and yellow particles, according to everyone's junior high school physics knowledge. For algorithm rule, we want to draw a rough picture. It is roughly going in this direction. It will actually be closer to the direction of the grain size. It is our read area. Then look at our yellow to read grains. Because we have 5 particles on our side, this will produce 0.5 grains. The red pair of yellow produces a grain of 1. Then it will be yellow as a whole and will go to read. The conclusion is that the denser the particles, the more attractive it is. Okay, we return to our finance operation. Click on our solve solver. If you want to use the node, then solve in the DOP. Then you need to use this node, solve solver. I mainly use it here. Transform our density into our own. Then calculate a direction value for this density. We'll produce a vector. And then we can achieve the effect we just created. Then I also made some notes here. Remember density review we generated at the beginning? Did you see it? Here we set a density attribute to 1. All particles have a property of 1. You can see that it is actually sparse in some places. Some places are very dense. The dense part is the particle. Then use our BB analyze to generate the real in this direction. Here, we use Garan. It calculates a t-minus degree value. Then we calculate through our density. So there will be a low density to a high density. It creates a direction. Is a vector we just mentioned. Enter our point ball. The volume generated by density is connected to the third pore. The resulting vector is given to the second pore. It is convenient for us to comment on C. We use a volume sample to use our volume. Through our P- attribute. Here we need to D- regulate our vector. Then give us a score to control the size of our movements. Then add up our original position, so that the particles will go in the direction we just said, towards the dense direction. You can see that I'm connected to this density volume. This is mainly to make it the densest place. It is to stop moving, because we are densely populated with particles. It doesn't need to be moved. I just want to keep all the places close to the dense areas. So I imported this as well. The value here is determined based on my scenario. About 200 is a good value. Density is 200 in one place. It does not produce movement. That is 0 is the smallest place. It will produce a 1. Everything moves. Overall image. One of our effects is probably this. If you want to make the effect more obvious, Here I give a parameter. You can control this parameter. This particle oscillator method. I watched the Outmaster of Station B. It goes into great detail. You can take a look. The overall production of the two effects is like this. Then look at what I did here. Here I have retained some of my reboots. Hey, yeah, being life may be used in the future. So I kept these properties. Then here we set up some piece scales. Convenient for some subsequent rendering. A new mask was set up. You can take a look. Because I want to render it later. Make a part of the central source brighter. It might be a little darker next to it. This allows me to create a black and white mask through this mask. It can be understood as a vertex map. And then there is a simple vax. Dealing with life with A. So it gets a value of 0 to 1. These are here. These are just some small balls floating around. We can talk about our camera is going to see it. It will go at 70 minus 5 frames. Wait. You can see that it is floating upwards. And then it comes with some animations. Then added displacement. Replaced with some animations. After that, a subdivision was given. Kaeru mo. It just moved. And then the overall effect is like this. Let's look at it again. A large ball is derived from here. Then the small balls around it. It is the back mirror plate. The big ball given by the material side. The outside is an ordinary glass material. Nothing special. The back mirror plate gives a gradient with color. The particle here is the mass property we derive. Then some of them have a brightness of 5. Some of the brightness is 2. The ball is also given. Like its surrounding balls, it is also made of glass. This is a render by default. The lights here. I just hit a few background lights. Then there is light at the edges. A background light. Hit on our backdrop. Let some highlight areas be created here. And here I add one. A light on the full ball. Like this edge, I want to have a little light and shadow. Light up below and you can see that this area will brighten. The main thing is to light up this area. The main thing is that the atmosphere is achieved by the light of this nail. And this whole thing is sunlight. This nail is mainly given to 1. Similar to this black and white map to the light. After giving the light map, we need to go to one of our render settings. Go to the render settings of if hour. Set this up. Then in the advanced options, there's a volume scattering here. Turn it off first. After turning it off, there is no effect. Hit this. And here is the control of this nail effect. Good. Generally, my rendering of this one is actually over here. You can see that the picture is actually some simple post minus production in AE. The main thing is to pull some levels apart. Of course, you can also adjust it roughly here. Here on the FR side, it will have one of its own post minus effects. Let's take a look at the later stage of AE. And this is an overall effect in the later stage. Here, I tone the color more red. Because of the tone of the whole film. The tone of the film made at that time was reddish. Take a quick look. Then, this is effect rendered. You can see that, compared to just now, it will be much grayer. But there is actually a Chiarossi relationship between it as a whole. For example, this piece is bright. This piece is slightly darker. There are also pieces like balls. And here I adjusted the color for a background. Then he pressed the vignetting corner. This is to kick out our ball. Stack on top. This is to give our balls a sack of brightness. Then I stacked a few rendered channels. These particle did some background particle animations. Then put it all over. The whole is such an effect. Okay, this is a quick demonstration process of this effect. I hope it can help you. Of course, you can continue watching the next video. There I will introduce the entire animation, production, and detailing completely. From the beginning of the ball to the final effect. See you in the next section.